All right, so yes, you should all have this table. This is called the T table, and if you're coming in just now, grab a table. And if you came in and you didn't get a table, you can come forward and grab a table here. Okay. I'll cover this in later. I'm pretty sure we'll get to it, but there's a bunch of conceptual stuff I want to cover first regarding hypothesis testing. Okay. So we'll start off with hypothesis testing, and this will be conceptual stuff. Okay, so conceptual stuff. So earlier on, we've talked about the significance level. Okay, what is the letter that we use for the significance level? Yeah, the significance level alpha. Okay, and how do we use the significance level when it comes to making a conclusion? We compare the p-value to alpha to decide whether or not to reject the null hypothesis. Okay, and so kind of just the broad overview rules is if the p-value is greater than alpha, what do? Do not reject the null. And if the p-value is less than alpha, that means we do reject the null. Okay. And we said if alpha is not specified, the default choice of alpha is 5%. Okay, so we generally choose alpha equal to 0.05 by default. Okay, so I want to say a few things. This choice of 5% is arbitrary, but 5% or whatever we choose for alpha, I'll write this. Our choice of alpha reflects our willingness to make a mistake. We'll say to make an error. And I'm going to put in parentheses type 1. Okay? There are, as the field of statistics and statistical inference was being developed, people realized, there are errors that are inherent to the process of making conclusions. Okay, there are errors that are inherent to the process of statistical inference that cannot be avoided. Okay, so I'm not talking about mistakes that you make because you put in the wrong number or you use the wrong p-hat or something like that. But these are just unavoidable mistakes coming from the fact that we are trying to make a conclusion based on limited data. When you don't have all the facts, there's a chance that you can be wrong. Okay, and these, the statisticians recognized that there were two types of mistakes, and at the time they were not very creative in the naming of them, so they called these the type 1 error and the type 2 error. Later on, we came up with better names, such as false positive and false negative, but the names type 1 and type 2 error have stuck around. Okay, so our choice of alpha reflects our willingness to make an error. So we'll say there are two types of mistakes, or two types of errors, and they are called type 1, and I'll explain all of this in a moment. Type 1, and this will be the false positive, and type 2, the false negative. There are two types of errors. These errors are inherent and unavoidable to the process. Process of making conclusions based on limited data. Okay, so let me explain the type 1 error and the type 2 error. Okay, well first let me just talk about ideal scenarios. Do I need to flip back? I don't know if you guys got all of that written down. Okay. All right, so we have, in the ideal scenarios, if the null hypothesis is wrong, we will reject it. And if the null hypothesis is right, we will not reject it. Okay, so those are the ideal scenarios. If the null hypothesis says the proportion in the bucket is 17% green, okay, and it turns out that the proportion in the bucket really is 17% green, I hope we don't reject that, okay? And on the other hand, if it says the proportion in the bucket is 23% green, but in reality the bucket's 17% green, then our conclusion, ideally, would say that null hypothesis is wrong. The proportion is something other than 23% green, okay? These are the errors, okay? The type 1 error, this is the false positive. This is, in truth, or in reality, the null hypothesis is correct. The null hypothesis is true or is correct, but our conclusion is to reject it. Right? So it's not that we've made a mistake, but it's just that perhaps because of random sampling, we happen to get a weird enough sample that leads us to reject the null. It's not that we've done something particularly wrong, but it's just something inherent to the random sampling process. So it's just we did not make a mistake in the math. But because of random sampling, we happen to get, quote, I'm going to just put in, quote, weird looking sample that led us to the wrong conclusion. So, for example, the bucket could truly be 17% green, but because of random sampling, perhaps we get a random sample that was 28% green, okay? Just because of random sampling. And when you do the math, it turns out that 28% green has a p-value of like 2%, leading you to reject the null hypothesis. But in truth, the bucket really is 17% green, just we got a weird sample. Okay, so you know, example. Okay, and in reality, the bucket is. Really is 17% green. Okay. But you know, our random sample ends up, we'll say, 28% green, and our calculations give a p-value. I'm just making up stuff here. 0.02. Okay, we reject the null hypothesis. But that was the wrong conclusion. Okay, based on the data, it is correct that we're supposed to reject the null hypothesis. But because we're dealing with just a limited sample, there is always a possibility that the random sample we're looking at is not really reflective of the population. So that's always a risk that we run, type 1 error. So that's the false negative. In reality, the null hypothesis is true, but our conclusion is to reject the null. I guess that this should be the kind of the summary part that is important. Okay. So if that's the type 1 error, what do you think is the other error, right? So we've listed off the scenarios. Ideal scenario, if the null is wrong, we reject it. If the null is correct, we will not reject it. Type 1 error is the null is correct, but we reject it. Type 2 error, what is this? This is the false negative. And this is, in reality, the null hypothesis is false or is wrong. In reality, the null hypothesis is false, but our conclusion is what? If this is the error. The null is false, our conclusion is not to reject the null. So that's a mistake. Okay. And again, it's the same idea here. It's not that we've necessarily done something wrong in our math, but because of random sampling, maybe we got something that didn't reflect this. Okay, so for example, the example here will be truth. The truth which is unknown to us. Okay, truth unknown to us is that the proportion is 17% green. Okay, so we'll say the bucket truly is 17% green. You know, our null hypothesis, maybe the null hypothesis says that the proportion is 25% green. Okay, so the null says the proportion is 25% green. Okay, and that's wrong, right? Because the truth is that it's 17% green. Our null hypothesis is wrong. Okay, null hypothesis is wrong. Okay, but let's say our data our data ends up as, a proportion, we'll say has p hat equal to, I don't know, 0.21, okay, 21% green or something like that, okay? And then when we do the math, perhaps 21% green ends up having a p-value of, I don't know, 9% or something like that, okay? Our data has p hat equal to 21%. When we do the calculations, we get a p-value of I'll say 13%, 0.13. Okay, I'm just making stuff up, okay? So based on our p-value, we do not reject the null hypothesis. Okay, but we should have, because the null hypothesis is wrong. Okay, but this is the wrong conclusion. But this, or we'll say this conclusion is not correct. Correct, because the null says p is equal to 0.25, but in reality, p is actually 0.17. Okay, and so this is a possibility. So when you get p equal, if your null hypothesis says that the proportion green is 25%, and based on your data, you get a p-value that's not extreme, that might be the wrong conclusion. Okay, and when you're going through the test, you have no idea. You're just going off of what the p-value says. This is the best we can do, but it might not be the right thing. Okay, so this is the false positive, and this is the false negative. Okay, now earlier I said our choice of alpha reflects our willingness to make a mistake. Okay, and alpha is actually equal to the probability of a type 1 error. Okay, so when alpha is 5%, we are saying that we are willing to make a type 1 error 5% of the time. Okay, so we're saying we're willing to make it a type 1 error 5% of the time. And you might say, well, I don't want to make type 1 error. I should just pick alpha equal to 1% or alpha equal to 0 or something really small. Why would I be willing to make a type 1 error? Well, the risk of type 1 error is connected to our risk of type 2 error, and they work in opposite directions, okay? So, why not just pick a small alpha to avoid type 1 error? Okay, well, the answer is if we reduce type 1 error by lowering alpha, okay, we increase our risk of type 2 error. So alpha is the probability of type 1 error. Alpha is the first letter of the Greek alphabet. Beta would be the probability of type 2 error. Okay, beta is the second letter of the Greek alphabet. So alpha looks like the letter A, first letter. Beta looks like the letter B, that's the second letter. So you have type 1 is alpha, type 2 error is beta. Okay? Actually, that's where we get the word alphabet from alpha and beta, just stuck together. So anyway, we increase our risk of type 2 error if we just decrease type 1 error. So there's a balancing act, okay? If we want to avoid type 1 error, sure, we can reduce type alpha, but we will increase our type 2 error, and vice versa. If we want to avoid type 2 error, we can increase alpha, but that increases your risk of type 1 error. The only way to kind of reduce both is to gather more data, but gathering more data is generally an expensive process. So you know, we do the best we can, which is in all of life, right? Okay, so if we reduce, let's see, we increase our risk of type 2 error. We have direct control over alpha, but we do not have direct control over beta. So we get to say, I want alpha to be 5%. I want alpha to be 10%. I want alpha to be 3%. We can say that. Okay? Beta, you can't just go around and say, well, I want beta to be 5% or 6% or something like that. Okay? It's subject to a bunch of other stuff. But there is that relationship that if you want to avoid type 2 error, you can increase alpha, and if you are willing to make more type 2 error, you can decrease alpha. Okay, so, you know, when do we want large and small alpha? This depends on how bad type 1 error is versus type 2 error. Okay, so there are some scenarios where type 1 error is worse, other scenarios where type 2 errors are worse, okay? Okay, so let's imagine a criminal trial. Okay, and so in the United States, we always start off with the presumption that the defendant is what? Innocent, right? So we'll say the null hypothesis is that the defendant is innocent. And the alternative would be that the defendant is guilty. So one of these things must be true, okay? The defendant is innocent or the defendant is guilty, okay? And we presume that the null hypothesis is true until enough evidence convinces us otherwise, which is much like how a hypothesis test works, right? Okay. What are the conclusions? We can either reject the null or we do not reject the null, right? So if we reject the null, what does that mean? That means the judge or jury says, concludes, we the jury find the defendant what? If we rejected the null? Guilty, okay? Do not reject the null. That means judge or jury concludes what do they conclude? It's not innocent, but not guilty. Okay? So the jury never says, we, the jury, find the defendant innocent. They always say, not guilty. Okay? And in the same way that when we do a hypothesis test, we never actually say we accept the null. Okay? We always say we do not reject the null. Okay? Okay? So, you know, we say, do not reject the null. Okay? We do not say accept the null, or jury does not say innocent. Because, you know, a lack of evidence does not prove innocence. It just means there wasn't enough evidence to convict. All right, so ideal scenarios. I'm going to run out of space here. Okay, ideal scenario is that if defendant is innocent, jury concludes what? Jury says not guilty. Okay, or basically if the null is true, do not reject the null. Okay, and if the defendant is guilty, jury says guilty. So if null is false, reject the null. Those are the ideal scenarios. Okay? Let me just copy this over onto the next slide here. So this is our null and our alternative hypothesis. Sorry, do I need to go back again? Okay, we'll go back. We might not get to the table today. That's okay. I'm okay with that. We got Friday. We got all of next week. More than enough time to cover everything and review. And wish you well. All right. So these are the ideal scenarios. If the defendant is innocent, the jury is going to say not guilty. If the defendant is guilty, the jury says guilty. Okay, let's try our first clicker question of the day. Okay. In this context, what is a type 1 error? Okay. A, B, C, and D. Okay, let's see. Type 1 error, it's we convict a guilty person. We convict an innocent person. We acquit a guilty person. Or we acquit, I hope I'm spelling acquit correctly, acquit an innocent person. Okay, oh, sorry, let me get the clicker software running here. So if you need to talk to your neighbor, you can talk to your neighbor, and we'll get this running here. So what is a type 1 error? What is a type 1 error? Okay, it's going to be one of these 4 choices. Okay, I'm gonna hit stop here. So get your clicks in if you haven't clicked. Okay, oh, great. Everybody, well, not everybody, 92% of you are correct. Okay, a type 1 error is we convict an innocent person. This is The null hypothesis is true, but we conclude reject the null. So that's convicting an innocent person. Which one's the type 2 error? I don't think we need to do a clicker question here. So acquitting a guilty person, this is the type 2 error. Okay, the null is false. But we do not reject. We do not reject the null, okay? And then this is ideal. And this is ideal. Okay, this is what we want. So ideally, we convict all guilty people. Ideally, we acquit all innocent people. But sometimes we make mistakes. We might make a mistake and convict an innocent person. We might make a mistake and acquit a guilty person. Which of these, between the type 1 and type 2 error, at least on a, maybe from a philosophical standpoint or whatever, and there's always up to debate here, but which is worse? Which is worse, the type 1 or the type 2 error? I would say the type 1 error is worse, okay? So, you know, I mean, you know, people, we can have a debate here about which one is worse. But I would say the type 1 error is worse, at least this is how we are trained. And, you know, especially if you think of like a capital punishment case where, you know, somebody might be executed for their crimes, I think it would be quite terrible if we execute an innocent person. But sometimes, you know, sometimes these things happen. Okay, so the type 1 error is worse. If the type 1 error is worse than the type 2, okay, so type 1 error is worse than type 2, do we want to use a large or small alpha? Type 1 error is worse than type 2. Do we want a large or small alpha? All right, you know, let's make a quick clicker question out of this, okay? So we have type 1 error is worse than type 2 error. Okay, so this is like, you got a 50-50 chance of getting it right or wrong. Okay. Do we want a large or small alpha? Okay, so A is we want large, B is we want small. Small. Okay, second question. Do we want a large alpha or do we want a small alpha? If we've said the type 1 error is worse than the type 2 error, okay, we'll say get your clicks in. Talk to your neighbor if you want. Somebody's clicking D or C. Don't. You should click A or B here. Okay, good. All right, I'm going to click stop. Somebody's still clicking the wrong letters here, but okay. All right. Well, I can't. Okay. So you know. And the answer is indeed B. Okay. So, yeah. So small alpha is preferred because what? Alpha is equal to the probability of a type 1 error. So if the type 1 error is worse, we want a small alpha. Okay, if type 1 error is worse, okay, and they say this, and if you were to serve on a jury, or at least at least in the movies they say this. No, they say it in real. What did they say? They don't say use a small alpha when you make your decision, but what did they say? They use the phrase beyond a reasonable doubt. Okay? They don't want people convicting someone because they have a gut feeling that the person is guilty. They don't want convictions just based on emotions and feelings, but they want it to be beyond a reasonable doubt here. Okay, that's what they say. Beyond a reasonable doubt is our way of saying use a small alpha. But they don't say with 100% confidence, right? Only convict someone with 100% confidence. Why would they not say that? So let's say you were a judge, right? So sometimes judges get to decide guilty or not guilty. And let's say you find out, you convicted someone, you said that you're the judge and you sentence someone and you say you are guilty, you're going to jail. And then later on, evidence comes forward, some DNA evidence comes out and it says, oh, you know what, this person, we got the wrong guy. This person was innocent, and so that person is exonerated, and you as the judge, you feel really bad about this. And you say, wow, I made a mistake. I never want to make this mistake again. I never want to convict an innocent person again, right? What is the only way you can be sure that you will never convict an innocent person again? Yeah, the only way you can be absolutely sure is to never convict anyone, okay? Because unless you know everything, unless you're some omniscient being, okay, you don't have all the facts. You cannot travel back in time, and you don't know exactly what happened, and so you can never be 100% sure about the story. And so if you never want to make the mistake of convicting an innocent person, the only way you can be absolutely sure of that is to never convict anyone. Okay? But if you are a judge and you never convict anyone, then you are not a judge. Okay? Because the role of the judge is to decide who is guilty and who is not guilty. And if you say everybody is not guilty because I've got this moral dilemma going on, then and it's a reasonable moral dilemma, but that you are not a judge if you never convict anyone, okay? So we'll say the only way to completely avoid type 1 error is to never convict anyone or never reject the null. Then you are no longer a judge. Okay, and then the flip side is also true. If you find out you let a guilty person go free, and that person commits a crime, and another person, another family is a victim or something, and then you say, okay, well, I want to make sure nobody gets off the hook. Everybody who's possibly guilty, we find them guilty. Then you say, I'm going to convict every single person that comes through my court. That's also no good. I guess everybody's leaving. I do want to say a little bit more here. I don't know what happened to all these rude people leaving in the middle of my class here. Okay, yeah, so I just want to give a kind of just a reverse scenario, another scenario where, but this time, another scenario where we'll say the type 2 error is worse than type 1. Okay? All right, and so this, sorry for the nature, but let's say such as a STD screening, okay? So generally, the doctors will assume that the patient is healthy or patient is disease-free. And then the alternative is if, some kind of something happens in the result, we'll say patient carries, some disease, okay? And so, what is, ideally, everybody who's healthy is said, okay, you are healthy, and everybody who carries a disease will be flagged as testing positive, okay? So, so ideally, all healthy people test negative for the disease, and all, we'll say disease carriers will test positive. All right. Okay, we have type 1 error and type 2 error. Type 1 error is the false positive. This is a healthy person is flagged as positive. And a type 2 error would be someone with the disease tests negative. This is the false negative. Okay, so we'll say a disease carrier tests negative. Now, both of these scenarios we want to avoid. We don't want, type 1 error really sucks for the person who's healthy, okay? But as far as kind of like a epidemiological mindset or viewpoint, the type 2 error is worse, right? Because the type 2 error means someone who actually carries the disease, believes him or herself to be healthy, and may then further spread the disease to other people. And so a false negative as far as, epidemiology is concerned, a false negative is worse, okay? And so, same goes for like cancer screenings and things like that. Those tests will generally have a higher alpha to just kind of flag any kind of scenarios there. Okay, we'll end there, and we'll see you guys on Friday, and then we'll take a look at the table on Friday.